Hello everyone, my name is Milos. I'm a software engineer and lecturer, mostly interested in cloud computing, web and mobile development, VR and AR, games programming, and AI. I work as a lecturer at the University of Westminster in London, UK, and I also work as a director of a digital agency called The Lab of Dreams. We specialize in building VR and AR software for training and education. So this is what I will be talking about in my presentation. So we will take a look at different applications of AR and VR that can be used for training and education. Let's get started with the first application. The first application is a VR training software for ship crew. It is built for Oculus Rift and HTC Vive, and this software is a dockyard simulator. It is built as a proof of concept to showcase what is possible to do, what kind of activities we can demonstrate, and what is that we can train the ship crew to do. Now, training on simulators is very expensive and it's not always available. So this was the motivation for building this software. Now, there are many different activities that users can do. So the main focus is on how to behave in case of emergencies such as fire, water leakage, or when it is necessary to fix faulty machines. But there are other activities, so we can use this software for training, for example, performing inspections of facilities, taking readings of different sensors, and finally installing, repairing, or managing different machines. Now let's take a look at how this works in action. So on the left side we have a video of this VR software. So what you can see is our VR environment. So we can use controllers to teleport, and we can teleport to one of these points, and here we can use the controllers to control the machine. So we can move the crane, and we can also rotate it. Okay, let's teleport to the next point, which is a table with tools. So as you can see, we can pick up different tools, we can toss them around, and we can also interact with other objects. So as you can see, we can just move this object and collide with other objects. Let's move on to the next point, which is the water pump. So we just started the engine, and as you can see, the water starts leaking. So what we need to do is we need to close the water valve so that we prevent water from leaking, and we have to repair this machine now. So we have to teleport to the table with tools, we have to pick up one of the tools, and we have to fix it. Now this is obviously not how you would fix this machine, but like I said at the beginning, this is just proof of concept to showcase what is possible to do. Okay, let's teleport to the next point, and we're going to start up this compressor. As soon as we start it up, we can see that it is now set on fire and the alarm goes on. So we have to teleport to the fire extinguisher, and we have to put out the fire. And once we successfully do this, we can see that the alarm goes off, and that means we are done. We can move on. So the software can also be used to get the new members familiar with the environment. And another aspect of where the software can be used is entertainment. So crew on ships spend a lot of time. So they sometimes spend weeks at sea. And it is very important to offer crew members entertainment because they don't have many options. When you're at sea, you don't really get many options to choose from. So we have this part where they can just practice archery or play around with a bow and arrows. Okay, so this is Dockyard Simulator. Let's take a look at the next application. So this is an AR application built for Microsoft HoloLens device, and this project is done for CTBTO organization. So this is the UN organization for preventing illegal nuclear tests. So the idea is to provide UN staff members with software that will help them to keep track of where they need to go, which sensors they have to visit, and they have to take readings from these sensors. So the idea is to use this AR software on Microsoft HoloLens, but outdoors. If we want to use this outdoors, we have several issues. First of all, HoloLens 2 does not have GPS. So we have to find a way to somehow get geolocation data. So we need to get latitude and longitude. The second problem is that there is no internet connectivity outdoors. So we also need to find a solution for this. And it seems that the solution is very simple. So we can actually use a mobile phone as a GPS source. And we can also use a mobile phone to share internet with the HoloLens device. So a mobile phone can act as a hotspot so that a HoloLens device can connect to the mobile phone and get access to the internet. So to actually set this up, we need two applications. One application running on the mobile device, so this is the server application, and a client application running on a HoloLens device. So we have to have a way to establish communication between these two devices, and for that we can use WebSockets. Using WebSockets, we can pass the location details from the mobile device to the HoloLens. Now let's see how this works. So first we're going to start up the mobile application. And as you can see, the mobile application is very simple. We just have two buttons, start and stop. So we can start up the server or we can stop it. In this input field, we cannot really change the IP address, but this shows up the IP address and the port on which this application will be running. So if we start it up, now we can see the latitude and longitude, and we have to type in the exact same IP address and the port. And when we press the connect button, we can see that we successfully established a connection with the mobile device. We are now connected, and we get latitude and longitude. To test everything out on HoloLens with essentially build a map that shows the current location, and we also show the weather forecast for the current location. Okay, let's move on to the next application, which is Linksys. Now this is probably the application I'm most proud of. I believe this is one of the most challenging projects I've worked on. So Linksys is an AR application. It is developed for HoloLens 2 to facilitate safer navigation and operations at sea. So there are many different features. First feature is Route Planner. So Route Planner allows us to specify the destination where we want to go, and the software generates possible routes. So the software is capable of detecting where we are, and based on the destination we get routes how to get there. Next feature is undersea topology. So this feature allows us to visualize chart data in real time so that we can see and avoid hazards beneath the surface. Next we have ECDIS charts. Now ECDIS stands for Electronic Chart Displaying Information System. Now, this is something that each vessel has, and you can think of it as a computer that shows up digital charts. So we have a feature that displays S57 or S63 maps. So these are just some standards when it comes to digital charts. So we can display these kind of charts, and we can visualize the data even when you're on the deck or away from ECDIS. So if you put a HoloLens device on and get on the deck, you can still see the ECDIS data. Next feature is nearby vessels. So this feature allows us to see other vessels and information about them even when they're not visible to the naked eye. So this is very useful in cases when, for example, we have bad weather like fog or storm or rain, or even at night when the visibility is very low. Next we have route weather. So with this feature we get detailed weather data for all points along the route. So this includes estimated time of arrival to each point, and we also take into account the time zones, because if we, for example, travel from London, UK to, let's say, Singapore, so this trip can last 3 to 4 weeks, and we will be going through several different time zones. So it's very important to take all of that into account. And finally, we have configurations. This is where we provide details about the vessel. So the details we need to provide typically include draft air, and some more details that can be very helpful for helping the software learn more about the vessel. Okay, so this is the ECDIS configuration. So this is a screenshot from the software. I will show you a video of how this works in action in a moment. So as you can see, we have to connect to the server application that runs on ECDIS. So this is a client application. And when we connect to ECDIS, we will be able to get geolocation data. And we have to provide some details about the vessel we're on, such as width and depth or draft. So this is very important. So this is what route planning feature looks like. So once we activate route planning, we see the route to the destination visualized. So as you can see from this screenshot, there are different colors for different parts of the route. So the first part is marked in green and the second part is marked in red. So this means there are some unsafe parts of the route which make this route unsafe, because all the parts of the route, they have to be safe for us to take this route. So if we hover over one of these points, then we can find more details. So we can see that there is one danger, and that is deep area. So we cannot take this route if we are considering it, because the water depth at one point is not deep enough. So we have to modify this route, or we have to use a different route. I will show you this in action in a moment. The next feature is undersea topology. And when we activate this feature, we get red rectangles, as you can see. And this shows us the danger areas. So we should not go beyond these red rectangles. If we hover over one of them, we again see more details, such as the water depth at that point, the distance, how far this rectangle is away from us, and duration. So this is how much time it is going to take us to get there. Next, we have nearby vessels, and once we visualize nearby vessels, we get yellow cubes. And if we hover over one of these yellow cubes, then we get this pop-up which shows up more details about the vessel. So we can see the position of the vessel, speed, heading, the ship name, what type of ship this is, where exactly the ship is going, and some more details like length and width and so on. And finally, we have a map. So now this is a 2D map, and this is what we get once we activate all the features. So the blue circle is where we are, and the big blue circle is the radius. So the red circles represent the red rectangles. So these are danger points, while the yellow circles represent the nearby vessels. And the red line is the route we're taking. Now let's see all of that in action. So this is undersea topology feature. Once we activate it, as you can see, the red rectangles start popping up. Then we have route planner. So we can verify if a route is valid. So as we can see, there are parts of the route that are valid and other parts are invalid. And for us to have a valid route, all parts need to be valid. Finally, this is nearby vessels, and they show up as yellow cubes. And if we hover over one of these yellow cubes, we get more details. We also have a weather forecast. This is a weather forecast for one specific point. This is the current point, but we can also get weather forecast for the entire route. Okay, let's move on to the final application, which is Monks VR. Monks VR is software for building memory palaces in virtual reality. A memory palace is a technique which is used to build and visualize spatial environments in order to enhance the recall of information. So you can see Monks VR in action on the right side. So some of the core features of this software are building worlds and spaces. This is probably the most important feature. It allows us to build our own world, our own space, right? We have some, as you can see, tools that can help us build this out. So we can quickly build rooms. We can add different objects like fence or even mountains. So something that will, help us build out our space. Then we can create different pedestal structures. This is places on which we typically place mnemonics. Now, when it comes to memory palaces, we don't use any text. Instead, we use 3D models and images. So in the Monks VR, we can import 3D models and 3D images without even having to take off the headset and import them from your computer. Instead, you can do everything in software. So this is an example of pedestals. So we have different structures. And finally, this is an example of importing 3D models. So you just select a 3D model that you would like to import, or we have a search box that allows you to type in the 3D model that you want, and then you can just hit the import button and the 3D model will show up in the space. Monks VR is available on Steam. You can get it for free. I strongly encourage you to try it out. It is very useful software. It is mostly used for memorizing complex structures. It is very efficient when it comes to learning new languages. It is used a lot in medicine, law, or it can help, like I said, with pretty much anything that involves complex, memorizing complex structures. So here you can see some of the spaces that we build out with Monks VR. And with this, I think I'm done. So thank you very much, everyone, for attention.